Hey everybody, it's Bruce and the Dog on the Floor, and today we're going to be doing some back of the napkin election modeling. So nothing serious that you should bet your life or your career on, but something that just kind of shows how some of this stuff works. So this is a map of the United States election, and it's really not a popular vote thing. It's really an electoral college thing where each individual state has a certain number of votes, and the winners of the states are going to get these votes. And so there are a couple of different election forecast models. There's one by a group called The Economist. They think that Biden is really likely to win, really 6 chances in 7. And then there's another one that's by a group called 538. So we'll look at their projects and their election model, which is right here. And you can see that that here, Biden is also a favorite, but more like a 72% chance. So I want to basically dig into this a little bit and talk about what goes into these types of calculations. So we're not going to, obviously, we're not going to get as deep as these folks do. They do this for a living. What we're going to do is just have some really rough chances for each individual state and then run a simulation and see how things will work. So the first thing that we need to do is to go into Julia and think about how we're going to represent a state. So in Julia, we have data structures called tuples. And so this is an example of a tuple. So maybe we have a state with the state itself, and let's say electoral votes, and Texas has 38 of them, and then let's say odds, or let's label this odds, or say Biden's chances as the favorite. It might be easier to list it that way, and let's say that he has like maybe a 1 chance in 4 of winning Texas. So I can then get the state, or maybe this is the name, something like that, right? So this is a pretty good representation. So I could have a state dot name. I could have the state dot Biden. So that's a 25% chance to win. And maybe I want to do this as a 0 to 5 like that. So then we could write a function to see how likely is it that that a particular candidate wins. And so maybe what we want to do is simulate one election outcome and get the expected number of electoral votes, which remember is going to be either 38 or 0 in this case. So let's run a simulation for a state. So I'm going to define a function, and that's going to be simulate. It's going to take a state, and I've got to resist having the do's and ends the same way that they are in Elixir with every fiber of my being, because I've been immersed in that language for a little bit. So I'm going to say if, let's say random. So this is going to generate a random number from 0 to 25. But if that is less than state.Biden, we're going to, that's a win, right? So if it's less, if it's less than or equal, well, let's just say if it's less, that's going to be enough, because this has a pretty high degree of precision. So we're going to say if it's less than or equal to, we're going to return state.ev. Otherwise, we're going to return 0. Right? Okay, so we can say, so simulate state. Okay, the winner that time. Okay, so we can actually So now that we have one state, let's go ahead and build a bunch of them. And so I think that the way to do that is to take some data, and I've gone ahead and extracted some data into a spreadsheet. So those are the economist numbers. Let's take the, and I really don't need the odds of Trump winning because it's basically going to be 1 minus the odds of Biden winning. So let's just grab this much. And I'm going to take that and we're going to open an editor. So I'm going to go ahead and drop some data into this spreadsheet. And let's normalize this a little bit to make everything like a constant width. Let me point out what I'm doing here. So this data is not all the states data because that would be just kind of maddening to create. This is actually the swing states that we think are going to be the most competitive. So our back of the napkin is going to be more of a evaluation of who's likely to win the swing states. And then we'll just kind of assume that the likely states will either go to Biden or Trump respectively. So that's the state. And we probably want to open parentheses, right? That's the state for everyone. And this is the EVs. And this is the Biden. Okay, so I have that much data, and so I can close the parentheses like that. So this is effectively a list of tuples. So I ought to be able to do something like this. So let's see if this works. So I'm in Julian. I'm going to say states is equal to, and then that data right there. Okay. So you can see that this is extracted. It said I'm going to build an array of named tuples, and the name tuple has these individual names, and the tuple has these data types. And so what's cool is that I could say, now I can say, let's see, a simulation, what does it look like? So simulate the state. What is that? So that's the function that we created. So I'm going to say but I'm going to use this dot here instead. So this basically gives me the number of electoral votes that I could expect. What do we do? That Biden is going to win, isn't it? So then I can basically get the sum. Right? So that's 134 electoral votes. But that's really not what I'm doing, right? Because we're only doing swing states. So if we look at the election, we can see that Biden has 212 electoral votes by default. So we need to add that. So let's say expected Biden votes. So this is a function. And I'm going to take the states. And this is going to be sum of simulate Yeah, I don't like that because we've named the states the same way. So let's call this a state group. No, what we want is, okay, we want to build that function again. So function expected Biden votes, electoral votes, and that's going to be the state group. So what I want to do is I want to simulate right? Because I might want to run this same simulation for another group and see how those are different and why they're different. But what I really want to do is add this to 212. Okay, so now I can say, I could do something like this. I could say, expected, not defined. What do we do here? Oh, yeah. Okay, so in that run, so in these runs, looks like Biden is doing pretty well. Lost this one and won these because you need 265 to win. So we can do a couple of things here. One of the things that we could do is run a bunch of these and then plot a histogram. And so let's see if let's see what this looks like. So we could say plot or histogram. Or how do I run a bunch of these? We're essentially going to use a for comprehension to run a ton of these over a range. So a range looks like this. So let's do a for. Okay, so we're going to do a for comprehension, and this is what I did. I basically looked for Julia for comprehension, and I found this bit of data right here. So I know about list comprehensions and for comprehensions because Joe Armstrong, one of my mentors, his favorite language structure was the comprehension, and so I kind of I'm drawn to those. So so what we want is expected Biden EVs, and I'm going to pass states. So I'm going to run that for X in 1. Let's just run 1,000 of them. Okay, so let's say runs EV Biden EVs, right? Okay, so now I ought to be able to say, give me a histogram for Biden EVs. Okay, so this will take a little bit of time to run. We'll let it pick that up. Okay, and is this guy right here? Yeah, there it is. Okay, so you can see that 269, this is what it takes to win or something around there. We could see that Biden is the overwhelming favorite with, looks like the median number of electoral votes that we expect it to pull is somewhere around 320, 325, and that's a lot of electoral votes. But let's go ahead and play with the data a little bit more. So we ought to be able to do a count, and we could say Biden EVs, but we want to count. We want to pick off the ones where X is greater than 269. So a tie is not going to do Biden any good because he doesn't control the vice presidency, which matters. In a tie, I don't know. So let's just say a Biden outright win has to be more than 269. So and 964 of those. So if we ran more. So let's run 1, 2, 3, 4. Is that right? Yeah, okay. So we're going to run a ton of those. And let's count these now. Yeah, so it looks like in 96% of our simulations, Biden is a winner. So to me, that says that they're building in a lot more uncertainty than we are, probably in the way the random numbers are chosen. We probably spread out the standard deviations or something like that. Or just in the individual calculations after the result is built. So so including this far out from the election, including some type of fudge factor, some type of uncertainty index is really important because, well, polls can change over time, especially when things are going crazy. When we have such big political uncertainty and economic uncertainty, and even with the coronavirus. So those are all things that could affect the election. So so we got a number of 96% based just on the swing states. And, I don't even know if this math is right. We haven't double checked it or anything, but it looks like we see a good, a good 20 points beneath what we have. And I bet if we ran the numbers for The Economist, which is a different simulation, I bet it would come back differently. But so our goal here is not to say this is who's going to win the election, but this is basically showing how we can use Julia to play with the data and see what's happening here. And I really have a tremendous amount of respect for people like Nate Silver, who spend some time trying to educate us not just on what they're doing, but actually building visualizations. And you could see that the Julia language gives us some extra tools for those visualizations. Like we built this histogram, and we could immediately see what was going on with the data, that the preponderance of this mountain was to the right of what's needed to win for Biden. So we could immediately tell what was happening, and that in fact our election results are along a normal distribution, which is interesting. But that visualization is really an excellent thing. So next time we're going to get together and we're going to package some of these tools up, some of these ideas up in a Julia executable file. So you'll start to get the feel of how to use our tools, use our data tools to start to think about data. And that's the beginning of the data science. We're not yet getting into machine learning, but learning how to work with groups of data so that in the various packages within Julia is the first step in getting there. And that's an excellent thing. From Bruce and the dog on the floor, this is Groxio Learning.